Hi everyone, welcome back to another interview session with one of our guest lecturer in this wind power project management program. Today we have Mr. Prasanth with us. He is working with Bay.Wa renewable. He is in charge of this grid connection in terms of this hybrid as well as business perspective and business analysis kind of. And he has quite a bit of experience of working as an electrical engineer in different fields as well. Let's welcome him and let us learn a bit more about his background and the field he is working in. Hello, welcome in Wind Power Project Management interview session. Yeah.
Thank you, Chandan.
And a bit of where you are working in details and what is your current role that you are involved in. Yeah.
So, hello everyone. My name is Prasanth. I'm currently working as a grid engineer and business analyst at Bay.Wa Nordics AB. So we are with Nordics is the Nordics branch is basically looking after the Swedish and Finnish market, and my role in the company is basically to do the financial analysis of different renewable energy projects, and also help my colleagues with some technical questions or engineering questions that they encounter during the project development phase, or a bit on the EPC side as well.
Yeah, that's quite interesting. I believe that in terms of intermittency related to renewable energy, hybrid kind of thing, like they complement each other, particularly wind and solar, and when it coupled with some kind of energy storage, which might be BEES, which is battery energy storage system, that's even better in all aspects, maybe in terms of like the grid stability, a business perspective, and so on. So what motivates you and Bay.Wa to go and focus more on this hybrid technology?
That's an interesting question. So when we look into the generation and consumption pattern anytime, then it seems that they are a bit not related directly, I think, right? And also in terms of grid stability, when you think that is the biggest challenge is to have the production and consumption match each other as much as possible. Our let's say that the environmental goals that we have currently, when we want to increase the renewable generation in the system, then it's a big challenge to have that synchronization of the frequency or to match the consumption and demand, basically. So in this regard, what happens is when we use different technologies behind the meter and also couple it together and add storage, then we get more predictable power output, the energy output from the system. And it also opens up new revenue streams for the project overall. We can take part in different services, different frequency services as well, and also it improves the grid utilization of the project overall. So all of these economical parameters, also there's good for the technical parameters, coupled together, and we have better system performance as well. So this is quite a motivating factor for any developer to look for more mixed technologies or hybrid technologies for future.
Okay, that's quite a lot of benefits of going with the hybrids. So when we look at these hybrids, we know that hybrid is a kind of mix of different things. So in terms of renewable energy, what is it hybrid actually, and what kind of hybrids are there? Is it, I know there is a standalone one, which is the power plant produce and export energy separately to the grids, and hybrid, what is it hybrid and what kind of hybrid are there actually?
Okay, so basically what a hybrid plant is, that there are two or more generating technologies behind the meter, and also maybe it could be a storage system as well coupled together. So we can broadly define hybrids in, let's say, three different topics or broader heatings. Firstly would be, we call it co-located projects where
Okay.
there are like two different kind of technologies or three different kind of technologies in same proximity or in the periphery, or at least they are sharing the grid connection. But the thing is, the economic dispatch of each of the plant is not influenced by each other. So those kind of projects, we call them co-located projects.
Okay.
And then there are other kind of projects where they have the same grid connection, but their economic dispatch is controlled by each other. Just for example, you could say that you can use the batteries. You can use the batteries for providing the frequency services required for the plant, or balancing services as well. And you can also use the BESS. You can use the wind and the solar for charging the batteries as well. So each of the operation of the whole plant is influenced by each other, and those kind of hybrid we call are the full hybrid systems.
Okay.
And then there's another interesting concept which happens more on the superficial layer, or in terms of optimizing of different assets operation, that we call virtual hybrid. So these means that the projects are not virtually connected, but their operation is being such that their economic dispatch is being controlled through a control center. And we are trying to get the best revenue possible from the market by using these assets as a whole.
Okay, so I mean, virtual one sounds quite interesting. So just a bit about this virtual new concept thing. This is more or likely the same thing, but controlling is a bit different so that we can get the maximum economic benefit out of that hybrid system. Okay. So yeah, in terms of hybrid things, I know there is wind and solar, as well as a major portion will be like this battery energy storage system. So in terms of this battery energy storage system, how the market is reacting, I mean, in a sense that particularly in Europe, or if we say these Scandinavian countries, in terms of batteries, is it, I mean, the market is growing rapidly so that the new wind or solar plants can have more of this storage, or there is a shortage of battery supply? How is it the market?
So what we saw before a few years ago was we used to call it a honeymoon period for batteries. So the FCR revenues, which are like one of the major source of battery revenues at that time, were super high, and then you could basically earn back your investment in 2 years. Timeline, right? But now, since the competition has been growing, so the prices for these kind of fast reacting services has started to saturate a bit more. And it seems that now the market is being more mature, and we're moving a bit for longer duration storage systems at the moment. So the competition has been quite high, and we see that in the long term, maybe it could be MFRR services or arbitrage services that would be more higher revenues that battery could earn rather than short-term markets. So that's been the trend ongoing at the moment, and there are like around, I think, 8 gigawatt that we see are planned projects at the moment, and it's not sure that all of these would materialize, but the competition seems to be growing quite a lot.
That's a good thing to hear. I mean, in terms of all these renewable energy targets and so on, that's definitely, this energy storage system and hybrid system will definitely add some kind of boost in renewable energy as well, in terms of, as you say, in several sectors, considering both economy, finance, and well as policy, as well as this technical section as well. And now another question will be like, in terms of this new, I wouldn't say that much of new, but still quite new comparing to other technologies and so on. Is there any specific topics that you recommend to do further research on our current students? Is there any such that they might look into in details, like maybe co-location of wind and solar, mixing hybrids with battery and so on? Any suggestion on that?
Yeah, I mean, definitely it's very interesting topic for research, especially for students, right? I could recommend maybe you could try and see the optimizing of the capacity for
Mhm.
a wind and a battery project, let's say, right?
Mhm. Yeah,
How what would be the right sizing to be
Yeah,
used, right? And
that's
how
exactly it.
how the operation strategy would be.
Yeah.
That could be something interesting. And I would also say maybe you could do a bit more technical research on, let's say, having a wind and solar park, and
Mhm.
what would be the optimum operation strategy, or let's say which kind of solar panels. So like, is it
Mhm.
trackers, or is it gonna be the fixed tilt?
Mhm.
What is the optimum tilt that you could do so that you have minimum losses
Yeah.
because of the wind park and operation, or because of the wind park seeding on the solar panels as well. So
Yeah.
this could also be an interesting topic to look for.
Yeah. I mean, it's quite easy to say that we will develop both the plans together, but when you look at in terms of, okay, once you develop, that's it, but that the next important thing comes about the operations.
Yeah, exactly.
How can you operate those in a more efficient way so that
Mhm.
you can get the best out of both the
Yeah,
technology?
exactly.
Yeah.
Also, I would recommend, maybe there is other interesting thing about ice fall as well. So
Yeah.
that could also be like, how much should we, how far should we place it, and how
Mhm.
would be the good way to place the solar panels so that
Mhm.
the ice fall is minimized, or so like in terms of hybrid projects, those could be some interesting topics to definitely to investigate.
Yeah. But as we are speaking about icing at all, uh, I'm not sure. It's just a general question about the battery performance and all. Considering the cold climate in these regions, that's a positive or negative only in terms of battery. I know there are some demerits of icing on wind, maybe as well as some demerits on solar panel performance as well. But let's keeping that aside. Let's talk about the battery. How does that cold climate or icy climates is it beneficial or it is not beneficial for the battery?
So for battery, the very cold climate would also hinder its performance in a way, and we might have to add some additional resource that could have maintain the battery temperature. So it's a good blend of mix of both, right? So if we say if it's very hot, then also it's not very good, because then you need cooling requirements for the system, and your battery performance lowers as well. But again, if it's too cold, then also your battery performance is decreased, and you might need to invest additional capex to have some way to maintain the temperature of the battery system. So it's not good.
Yeah, and I mean, from what you said, if I understand, it's always a balance between all these aspects. Okay, that's good. That's good to know. And the last thing that we asked to all our guest lecturer is that any final words, any kind of suggestion to the current students, so that can be they can make future proof of their career, what is coming ahead in the industry, so that they can be prepared themselves before jumping into the industry.
Personally, I think there are like when I was studying, basically, we need to be very, let's say, open and bit broader in our thought process. When we say renewables, there are a lot of areas that you could look forward to, from, for example, from project development to EPC contracting, and like site management, to business analyst as works as well. From then on, you could also try and look for others, like operation technicians, and those are also some of the interesting fields that you could work on. And even more, if you're good in terms of codes, and if you think that AI is my future, you could also try and use AI and go a bit more to predicting better predictability for weather forecast, and that would be more the trader side work as well. So that is also interesting field to explore.
That's quite a good suggestion. And we love that you are here sharing your experience, thoughts, expertise with us. That is really helpful for the students. And thank you once again. We wish you all the best. Thank you.
Thank you very much.
Bye bye.